Hello and welcome to a video about ionic compounds. We're going to look at one or two of the properties of ionic compounds and how they relate to the physical features that the compounds might have. The first thing we're going to look at is this is supposed to be actually a magnifying glass looking at some common table salt, looking at some grains of salt, and as we know, salt is actually the compound sodium chloride. Now if we were to look in a great amount of detail at the structure of the particles in sodium chloride, you would notice it looks a little something like this. We've looked at how this is formed in a previous video, so if you're not quite clear about that, you can go back and have a look, and it's listed on my-gcsescience.com, but we'll plow on for the purpose of this video. So what we have is a structure, and we have a special name for this. We call this a giant ionic lattice. Okay, so it's a giant ionic lattice, and this particular one is made of sodium ions and chloride ions, which I've shown in the key on the side over here. And the ions are held together by what we call strong electrostatic forces, and these forces act in all directions from each ion. So if you took any one ion, it would be attracting its neighbor in all directions, and these, as we said, are strong electrostatic. Is that going to fit in? Yes, strong electrostatic forces which hold the whole thing together, and they act in all directions and between all the oppositely charged ions. Now, because of this feature here of strong electrostatic forces, ionic compounds have high melting points. So ionic compounds, in fact, they also have high boiling points. I'm going to be lazy and just abbreviate it. And the reason for these high melting points and boiling points is down to these electrostatic forces of attraction. So if I was to look at, say, this ion or this set of ions down here, imagine we were supplying some heat energy down there. What would happen is these ions would gain that heat energy, and they would then start to move. They will start to move a little bit more vigorously than they were before, but as you supply more and more energy, eventually they will break away from those forces of attraction. And because these electrostatic forces of attraction are quite strong, and because there are many of them in the structure, that means the whole compound has a high melting point and a high boiling point. It's because there are large amounts of energy required to break the many strong bonds. Okay, and you should be able to explain that with respect to giant ionic lattices and these electrostatic forces that require all that energy to pull them apart and therefore melt the compound. Okay, so that's just a brief outline of that. There's one more thing I want to go through, and that is the idea of conduction of electricity. So here's our compound sodium chloride, and what we can actually do is we can melt it. It will take a lot of energy, but we could melt it, and then we call it molten sodium chloride. So what we have here are all these ions that have been separated out because they've been melted, or the substance has been melted, should I say. And because the substance has been melted, all the ions are free to move about in this liquid. So each one of these can move about quite easily. And what that actually means, because these ions have a charge, the sodium ions have a positive charge and the chloride ions have a negative charge, if we were to put two what we call electrodes across or into the liquid, we have one that has a minus or is connected to the minus side of the power pack, and this is on the positive side or the plus side of the power pack. What happens is these ions can move, and they can actually move towards the electrode. So the pluses would move, or could move, to the minus electrode or the negative electrode, and the chloride ions could move to the positive electrode. And because they are free to move, what happens is this current is allowed to flow through this system. So the current can flow from one electrode to another because these ions can carry the charge across and therefore allow current to flow. That's not the only way we can do that. We can also actually melt the sodium chloride or dissolve it in water, and in a similar way the ions are free to move around. And remember, this is applicable to all ionic giant ionic lattice structures. The one they give in the specification is sodium chloride, and they say that's the only one you really need to know about, but it's equally applicable to other compounds. But in a similar way, the ions, because they are free to move around, they are able to go from one electrode to another and therefore carry a current. Okay, so that's a brief overview of the features of ionic compounds and how it affects the behavior in different situations.